Good day, students. On this clip, we're going to be going over two examples on how to convert angles between degree and radians, how to graph, indicated quadrants of the terminal side, and also what the reference angles are, okay? All right, so let's go ahead and write down the instruction for the examples. So for the given angles, write this down. For the given angles, A, express uh, the angle in degree and radian form. Okay, as the first task. After expressing the angle in degree and radian form, now you're going to graph the terminal side of the angle and indicate what quadrant it lies in. Indicate what quadrant it lies in. All right. And then next, you're going to find the reference angle. Find the reference angle and express it in degree and radian form also. In degree and radian form. Okay? All right, let's go ahead and take a look at question number one. For question one, we have theta equals 210 degrees. All right? So we can clearly see that the angle is given to us in degree form. So how do you express this in radians? So in radians, we have to multiply 210 by the conversion factor, okay? So for 210, we're going to multiply it by, we have two options, okay? Either we'll multiply by pi over 180 or pi radians over 180 or 180 degrees over pi. So which of these two do we select? We select the one that causes a degree to get canceled out. So since we have degree on the top, we're going to select this option because it has a degree on the bottom. And when I multiply, the degrees will cancel out, okay? So let's go ahead and put it in here. So we're going to multiply by pi over 180 degrees. All right? Put this over 1. Notice that the degrees cancel out, which is what we want. This pi right here is radians. And then we can divide top and bottom by 10, which involves canceling out the zeros. So divide by zeros. I mean divide by 10, sorry. And then now we're going to multiply across. When we multiply across, we're going to have 21 pi over 18. Can I reduce this? Absolutely. I can divide the numerator and the denominator by 3. That's the greatest common factor. So divide by 3 top and bottom. And then we're going to have 7 pi over 6 radians. Okay? So theta, the angle theta is basically, theta is 210 degrees or 7 pi over 6 radians. Okay? All right, so that's the answer to the first part. Now, for the graph, let's go ahead and graph this. All right, we're going to create our coordinate system. So we have the y coordinate and then the x coordinate. All right. Okay, so let's go ahead and graph theta. So we know that the angle that we're given is positive, right? So we're going to go in the opposite direction. So always start from the positive x, which is 0 degrees, And then we're going to keep going quarter of a full circle, which is 90 degrees until we exceed our target angle, which is 210 degrees, okay? So remember, going up is positive, going counterclockwise is positive, and then going clockwise, rotating downwards is negative, all right? So we're going positive because the angle is positive in this case, all right? So we go quarter of a circle, 90 degrees, smaller than 210, keep going, another quarter of a circle, 180. There's you add 90 to 180, 90 to 90, you get 180. Too small, keep going. Add another 90 to 180, you get 270 degrees. That's too big, we need to back off. So the terminal side is going to be somewhere here. Okay, so let's indicate what the angle is. So this angle that we have just graphed is 210 degrees, or uh, 7 pi over 6. Okay? And let's indicate the area that we swept, so we went in this direction like this. And that is, this angle that we just created is theta. Okay? So we have to indicate what quadrant it lies in. So it is in quadrant. What quadrant is it? This is quadrant 1. This is quadrant 2. And this is quadrant 3 right here. And this is quadrant 4. So since the terminal side is in the third quadrant, we're going to indicate that it lies in quadrant number 3. Okay? All right. Now, next thing we have to do is we need to find the reference angle. Okay? Find the reference angle. So, what is the reference angle again? The reference angle, let's call it theta reference. So what is the reference angle? The reference angle is the measure of the terminal side to the nearest x-axis, okay? So the closest x-axis to this terminal side is the negative x. So this angle right here, is your reference angle. Let me put it in blue. This is your reference angle right here, this angle right here, okay? So how many degrees is this? Remember, your reference angle is always positive, so we're going to subtract the bigger one from the smaller one, all right? So what is the angular separation from 210, between 210 and 180? What's the angle of separation? So to do that, let's go ahead and do the computations down here. Theta reference is going to be the bigger angle 210 minus 180 to find the angle of separation. All right, when we do the computation, we'll end up with 30 degrees. All right, so our reference angle is 30 degrees, but we have to express it in degree and radian. Okay, so in radians, you're going to have to multiply 30 degrees by one of our um, conversion factors. Okay, so remember we have two candidates, either pi over 180 degrees or 180 degrees over pi. So which one do we use? We use one that cancels out the degrees, which is this one because it has the degrees on the bottom, all right? So we'll multiply by pi over 180 degrees. Express this as a fraction also. All right, now the degrees cancel out. And then when we divide by 10, the zeros cancel out. We can multiply across. That will give us 3 pi over 6, I'm sorry, over 18 radians, 3 pi over 18 radians. And then we can reduce that further. To reduce this further, we're going to divide the top and bottom by 3. So divide by 3 and divide by 3. And that yields pi over 6 radians. Okay? So our reference, angle theta reference, is 30 degrees or 7 or pi over 6 radians. Okay, so there goes the reference angle. All right, let's indicate that in our graph. So over here is the reference angle. Let's put that in blue. The reference angle is 30 degrees or pi over 6. That's your reference angle right there. Okay, so there you have it. Now let's go ahead and take a look at question number 2. Question 2, we're dealing with a negative angle in this case, all right? So for number 2, we have theta equals negative 3, I'm sorry, we have theta equals, let's do negative 7 pi over 4, okay? Negative 7 pi over 4. All right, so part A requires expressing the angle in degree and radian form. So theta, as you might have guessed, is in radian form, okay? So we have theta equals 7 pi over 4 radians. So what we have to do next is express this angle in degree measure. All right, so theta in degrees will involve us multiplying negative 7 pi over 4 by the appropriate conversion factor, okay? We have two choices, pi over 180 degrees or 180 degrees over pi. Okay, so we're gonna pick the candidate that can help us cancel out this pi. So anyone that has a pi in the denominator will be our choice. Okay, so which one has a pi in the denominator? This one right here. So that's what we're going to use. So we're gonna have multiply by 180 degrees over pi, and you see what happens here. The pi's cancel out. So this divides out with that, which is nice. Okay, 4 does go into 180 45 times. So 4 goes here once, and then 4 goes into 180 45 times. And then when we multiply negative 7 by 45, we have negative 315 degrees. All right, so there goes theta in radians. So theta is negative 7 pi over 4 in radians, or so negative 7 pi over 4 radians, or negative 315 degrees. All right, so we're done with the A part. Now the B part, we have to graph this negative angle. We need to graph it and indicate what the quadrant of the terminal side is. So how do we graph negative angles? That's the question. All right, so let's create our coordinate system, our y coordinate and our x coordinate. Now, let's see. How do we graph negative angles? So we indicated earlier that you always start from your positive x. That's your 0 degrees, okay? If it's positive, you go counterclockwise or upwards. So this is a positive direction of rotation, positive. You go up and across. If it's a negative angular measure like we're dealing with in this case, we're going to go down and across, okay? Negative. So this is just a sketch as to where 315 resides, negative 315. So we're going to be going down a quarter of a circle until we exceed negative 315, okay? All right, so I'm going to put this in red because we're going negative. So go quarter of a circle, negative 90. Too small, keep going. Subtract another 90, we have negative 180. Too small, keep going, subtract another 90, negative 270. Too small, keep going, subtract another 90, negative 360. Well, that's too big. That means the terminal side is right here, okay? All right, so our terminal side is going to be right here in between negative 270 and negative 315. So let's go ahead and graph it. That goes our terminal side. All right, so what is it? What did we just draw? This is negative 315 degrees, or negative 7 pi over 4 radians, all right? So that's what this angular measure is. So let's indicate the region we swept. We went in this direction, like this, bam, and that's theta, all right? All right, what quadrant is this terminal side in? It's in quadrant number 1, okay? So it's in quadrant 1. Okay, now let's take a look at the C part, where we have to find the reference angle. So C is a reference angle. All right, reference angle again um, is the angular measure from the terminal side to the closest x-axis. Okay, so this is the terminal side. Which x-axis is closest to it? This is a positive x, right? This is too far. So since this is the closest x-axis, the reference angle is going to be this angle right here. this angle measure right here, that's going to be your reference angle. So the question is, how many degrees separates 315 from 360? So to get your reference angle, we're going to carry out the following computation. Theta reference is going to be 360 minus 315. Okay? Reference angle is always positive. Um, so that's why you drop the negatives, okay? So just forget about the negatives. So 360 minus 315 is 45 degrees. So there goes your reference angle in degree form. In radians, because we are expected to express it in degree and radians, 45 degrees, we need to multiply by a conversion factor. We have two choices, either pi over 180 or 180 degrees over pi. We need an option that cancels out the degree. So we're going to pick option number 1 because it has a degree on the bottom and this has a degree on the top. And when I set it up like this, you notice that the degrees cancel out. Okay, so put this over 1 so we can have two fractions. Now, this degree cancel out like we desired. 45 goes into 184 times, so 45 goes here once. 45 goes here 4 times. If you multiply across, you have pi over 4 radians. Okay, so our reference angle, theta ref, is given by 45 degrees or pi over 4 radians, okay? So let's go ahead and indicate what this looks like on the graph. So our reference angle again is right here. So this angle measure right here is the reference angle and it's 45 degrees, which is equal to pi over 4. All right, so there you have it. So thanks so much for taking the time to watch this video. Feel free to subscribe to my channel by clicking up here. And if you like this video, you can click like down here. And please, please, please post a comment and tell me what you think about this video. More clips can be found on mathgradserve.com. Thanks again and have a wonderful day.